students. As we are doing the separation techniques and we discuss the fractional distillation. Now discuss how we can separate the components of air. As you know, air is a mixture of gases. The components of air can be separated by fractional distillation. So what we do in this, let us discuss through first by flow chart. Air is compressed and cooled. How we can cool the air? By increasing pressure and decreasing temperature. So air is first converted into liquid air by increasing pressure and decreasing temperature. The liquid air is then allowed to warm up slowly in a fractional distillation column. Then the different components separate at different height depending on their boiling point. ये लिक्विड एयर है, इसको फिर हम धीरे धीरे गर्म करना शुरू करते हैं. किस में गर्म करते हैं? फ्रैक्शनल डिस्टिलेशन कॉलम मीन्स उस अपरेटस में. और जो गैसेस होती हैं वो अलग अलग, जिनका बॉइलिंग पॉइंट डिफरेंट होता है, वो डिफरेंट बॉइलिंग टेम्परेचर पर वो सेपरेट होना शुरू होती हैं. सो यू कैन सी द बॉइलिंग पॉइंट ऑफ ऑक्सीजन इज -183 डिग्री सेल्सियस, आर्गन -186 एंड नाइट्रोजन -196. सो विच gas will be collected first, which is having very low temperature, that is nitrogen. So first nitrogen will be collected, then argon, and then we will get oxygen. See, this is the diagram of the apparatus which is used in the separation of the components of air. Components means different gases from air. First of all, here is the filter paper. Air get filtered from here. Air is inserted and it's filtered so that the dust particle can be removed. And air comes to this chamber. Here the pressure is exerted on the air and the air becomes hot and passes through this component. Here the condenser is there. Water, freezing cold water is condensing the air, means making the temperature of air very low, and air becomes cool and it changes into the liquid form. So cold and compressed air passes from here. When it comes, there is a separator and the carbon dioxide comes out from this side as a dry ice, because when we decrease the temperature and carbon dioxide converts into the solid form and can be separate out from this separator, and that solid carbon dioxide everybody knows that is called as dry ice. Then liquid air passes through this. Here expansion jet is there, so there are the fractional distillation column, and here heat is provided and nitrogen comes out here, and then comes out argon, and then again the temperature is decreased and we can get liquid oxygen in this. The next separation technique is purification of solids by crystallization. All of you are familiar with this technique. Crystallization is a process of obtaining a pure solid in the form of crystals from its saturated solution. For example, by crystallization we can obtain pure copper sulfate from its solution. So first of all, what we do, we'll prepare the saturated solution of copper sulfate, and then we will heat, and then we allow for cooling and obtain the crystals. Dissolve about 5 grams of copper sulfate in minimum amount of water. Filter the solution to remove the impurities. Evaporate the solution in a china dish to get a saturated solution. Cover the solution with a filter paper and allow it to cool. Pure copper sulfate crystals are formed. So by this technique we will get the pure solid from its solution. Next is how we purify water at large scale. Everybody knows that fresh water we obtain from rivers, lakes, or groundwater. In this receiver, the water is collected from all these sources and then it passes through sedimentation tank where the solid impurities are allowed to settle. Then it passes to the loading tank where the suspended impurities settles, and then it passes to the filtration tank in which water is filtered through fine sand, gravel and coarser gravel, and then it passes to the another tank, chlorination tank, where chlorine and ultraviolet rays are passed to kill the bacteria, and then it passes for the supply to the homes. So in waterworks system, methods like sedimentation, loading, filtration and chlorinations are used to remove impurities from water. So that was all about mixtures, types of mixtures and methods to separate the components of the mixture. In that, alloy is also mixture, but that cannot be separated by the simple physical techniques. Now come to the types of pure substances. As you are familiar that pure substances are the substances which are made up of only one kind of atom. But pure substances are of two types. They are element and compounds. Element is a basic form of matter which cannot be broken down into simpler substances by chemical reactions. Elements are three types: metal, non-metal and metalloids. And all of you are familiar with metals. You know that they are lustrous, malleable, ductile, good conductor of heat and electricity. They are sonorous. For example, iron, aluminium, zinc, mercury, copper, silver, gold, etc. And non-metals, they do not have luster. They are not malleable and ductile. They are poor conductor of heat and electricity. They are not sonorous. Exceptions are there, but we are talking about general properties. For example, hydrogen, oxygen, nitrogen, iodine, carbon, sulfur, phosphorus, etc. And metalloids are the substance which shows the properties, few properties of metal and few properties of non-metal. For example, boron, silicon, germanium, etc. Compounds. What are compounds? Compound is a pure substance containing two or more elements which are combined together in a fixed proportion by mass. As they are fixed, they are attached chemically and cannot separated by the simple techniques. So compounds are also considered in the category of pure substance. Now, characteristics of compound. A pure compound is composed of same elements combined in a fixed ratio by mass. Means mass should be fixed. In mixtures you can take any ratio, but in compound the ratio is fixed. A pure compound is the homogeneous in nature. It is formed as a result of chemical reaction between the constituents of elements, and you cannot separate the constituent of compounds by simple techniques. The characteristics of compound. Properties of compounds are altogether different from the elements from which it is formed. Constituents of compound cannot be separated mechanically, and formation of compound involves energy changes. Basically, compounds are the result of chemical change and mixtures are the result of physical change, which you have studied in the previous classes. Physical changes, the changes which shows the change in shape, size, and no original property of the constituents are changed, but in the chemical change in which the properties of the product are altogether different from its constituents. Differences between mixtures and compound. All of you are familiar now. Mixtures, it is composed of two or more elements or compound mixed together. And it is composed of two or more elements, but they should be combined chemically. Second, the composition of constituents is not in a fixed ratio. You can take any of the constituent, any of the ratio. But in this, the composition of constituents is in a fixed ratio. For example, H2O, two atoms of hydrogen will combine one atom of oxygen. Next is, it shows the properties of all the constituents, but in this it shows the different properties than the constituents of element, which indicates that this is the physical change and this is the chemical change. The components can be separated by physical methods by using simple techniques, and the components cannot be separated by physical methods. They can be separated only by chemical methods. So that's all with this.